recording. I'm just going to record for a few moments to check if I start to drop frames like crazy. No, it's fine. All right. So, are you guys ready for another run? Okay, I think if I... There we go. Oh, yeah, so it jumps back to 0. One more and we are going. Import torch. Import torch nn as nn. Import torch vision. From torch vision... no. Import torch vision transforms as transforms. Import torch optim as optim. From torch utils data import data loader. What else? Import numpy as np. Import matplotlib pyplot as plt. What's extra we need? We have torch. I feel like there's one we missed. We'll find out if there's one we miss. Chill it out. In batch 16. Our train transform equal transforms compose, and it's gonna be transforms to tensor. This makes sure that the image comes into a convenient form for pytorch to deal with. So test transform is exactly the same. Now we're going to say train data is torch vision data sets MNIST root equal here root download equal true, and then what else is we can take here? Transform equal train transform, and that's it. Now we're gonna jump down here and we're gonna do a very similar one here. This is gonna be the test data and it's gonna be test transform, and then train loader is going to be data loader on, and it's gonna hit the train data, and we're gonna get batch size equal in batch. We're gonna get shuffle equal true, drop last equal true, num workers equal 1. Here, just gonna for the sense of order, we're gonna make a copy of this, call it test loader, and we're gonna, that one's gonna hit the test data, but it's gonna have it's not gonna shuffle. Oh, that's one of these is supposed to say train. That's these ones up here. Train equal true. Oh, but this one down here, train equal false. Let me check if this works. It does. So that's it. Now, class net. Now we're creating the neural network class itself. Definite self super net self init at self conf 01 equal nn conf 2d1655 1122, and we need 2 of these. Then we need self pool 01 equal nn max pool 2d. It's gonna have shape 22, and we're gonna need 2 of those. And then self lean 01 lean nn linear, and we need to remember that this one has to increase its channel width to 16, and it's gonna take 1677 and go down to 477. The next one is gonna go 4 to 1, and this one's gonna go 1, 2, 10. This is of course number 3 and number 2. Now we're gonna torch NN init Xavier, and it's gonna hit self conf 01 wait, and it's gonna do that for this one as well and for each of these. There we go, and then we're gonna go conf 01 bias data fill with, and this is just going to be a little cute number, because instead of in a sort of theoretical sense we should put there 0, right? But for numerical reasons it's a little safer to put a little cute number that's close to 0 but not actually 0. And the inaccuracy of doing so is very small, but it can save some numerical instability. So first we pass on the inside here, of course, we say on the inside we go to the convolutional neural network first, and then on the outside we have the pooling layer, and here we have the activation function where we're going to take sigmoid multiplied by x. I'm going to do that again here. And then down here we're going to change the view to -1 7 7 16. When we put in the view put -1, it means that that particular dimension is inferred by pytorch, even though it's not provided by us. And x equal torch sigmoid x times x. And then we take some more of these things here, these delicious things here, and return x. Let me check if this is correct, all of this. I haven't forgotten anything now, right? No, this looks cool. Let's check here. So that's this one. Now say net equal net, net here, and net equal net to CUDA, and we're going to say criterion equal NN MSE loss, and optimizer is going to be optim Adam net parameters, and here it's going to be LR equals 0 0 0 1. Come on. Yep. Good. And now we're going to build the test net. So this is going to take a net and a test loader. All right. Correct is 0 and incorrect is 0 for IMS labels in test loader IMS lige med IMS to CUDA. Output is net IMS. And our targets are equal torch arc max output on dimension 1. And now where targets fit with the labels, then this will be a true, then this new vector will have value truth. We change that to long, because then it's, instead of false truth, it's going to be 0 1, and then we take the sum of that, the item of that sum, and that is our right guesses. Then our correct guesses is incrementing right guesses, and incorrect is incrementing label shape null minus right guesses there, and it runs through there, and then it returns correct, incorrect. Boom. Now def train net net train loader. Oh, come on. here we're going to have one hot equal torch I of course the identity matrix, and it has 10 because we have 10 classes. CUDA and one hot and then it's oh my god, for yeah, imps labels in train load. Oh my god, we need also criterion and optimizer. Imps equal imps to CUDA, labels equal labels to CUDA, outputs equal net of imp, oh come on, of the imps. Targets is one hot's labels. Loss is criterion output targets. We need to go up here and reset the optimizer. And we're gonna say loss hist append loss item. And up here we put loss hist and empty list. And here we say loss backward, oh, and optimizer, oh come on, step, and return loss hist. Now we say res equal test, oh, net test loader. So just gonna run that, let that go running. So we say message is, oh god, what? Return, ooh, it's supposed to be. Yeah, message, measured accuracy is percent 2f percent as res 0 divided by, let's go ahead and call that 4 divided by sum of res times 100 print message while res 0 is less than 9902. We need our loss hist defined out here as well, a blank one. Loss hist plus equal train net train loader criterion optimizer. Then we get this here, this stuff here, basically this again, and then down here it's going to say print, come on, success. Come on, let's go now, come on, for reals. 9.2, that's fine. 9.2, that's the accuracy before training. So yeah, that's pretty much, you know, I mean, you take a random guess, there's 10 guessing which digit it is, there's 10 possibilities. So yeah, you're going to be around 10% of the time. You're going to just be accurate just by sheer chance. Oh, 98.8. Oh, we were so close to 99. Now we have to wait for another. Dude. Come on. Come on. 99%. Come on, 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 come on. Yeah. Stop recording.